Hi guys, so today we're going to be learning about representations of three-dimensional figures. Before we get started with example 1, let's look at isometric view, because that's what we're going to be dealing with today. Okay. So the view of a figure from a corner is called the corner view or perspective view. Okay. You can use isometric dot paper to draw the corner view of a solid figure. You can find isometric dot paper on my lessons in Populi. So if you go to lessons and this module, you'll find it there. Okay. So in this lesson, isometric dot paper will be used to draw and construct 2D models. It's two-dimensional because it's on a piece of paper of 3D things, of geometric solids, right? And part of the isometric view that we're going to talk about, there's different ways of seeing it. Left is on this side, right is on this side, and front is looking at it this way, and then top, of course, is this part that's kind of shaded there. Okay? So that's what you'll see a little bit on when it talks about left view, right view, front view, top view. That's what it's talking about there. Okay? So the first thing we're going to do is practice by drawing a solid. Okay? So here we want to sketch a rectangular prism, so kind of like a box. It's going to be 2 units high, 5 units long, and 3 units wide. So I'm just going to pick somewhere, okay, and I'm going to pick somewhere, and I'm going to draw it 2 units high. Okay, so you can use a ruler if you want, or just kind of sketch it that way. Okay, so it's 2 units high, so I'm going to start by drawing it here. Hopefully that's enough space. So 2 units high. Right, so note that it's 1 space here, 1 space here. Okay. It's going to be 5 units long and 3 units wide. So let's go long this way. So it's going to be 1, 2, 3, 4, 5. So this is 5 units long. Right. And 3 units wide. So here to here is 1, 2, 3. 3 units wide. Okay. So you can kind of already see it. Okay. And then again, it's 2 units high, so I'm just going to connect the rest of the parts. Okay, 5. So this is 1, 2, 3, 4, 5. Oui. Let's do this way. So 1, 2, 3. And there you go. And so there's my rectangular prism. Right. So 2 units high, 1, 2, 5 units long, 1, 2, 3, 4, 5, and 3 units wide, 1, 2, 3. And there you go. Okay. So why don't you try CYP2, and then once you're done, come check your answer. Okay, your sketch should look something like this. Okay. If you got something like this, you can move on to the next example. If not, here is your explanation. Okay, so triangular prism, so that means the bases are triangles. It's 3 units high, so that's where I actually started. So I just picked here and I went 3 units high. 1, 2, 3. Okay, then I want it to be a right triangle, legs 2 units and 4 units. So here I went down to 1, 2, and then 4 units, 1, 2, 3, 4. Okay, and then that kind of created my triangle here. Right, and so then I just continued the 3, and then connected, and then connected this to make the triangle. Okay, so that's how I did that one. Okay, so now, based off of the different views, we're going to draw a corner view of the figure given the orthographic drawing. Okay, so this is the orthographic drawing. Okay. It tells us what it looks like from the left, from the front, and from the right. Okay? So the top view indicates 2 rows and 2 columns of different heights. And we know that it's different heights because of this part here, right? The bolded lines here tells us. Okay? Okay. Then the front view indicates that the left side here, this part on this side, is going to be 5 blocks high, and the right side is 3 blocks high. Okay? The dark segments indicate breaks in the surface. So while part of it is 5, right in front of it is 4, while part of it is 3 blocks high, part of it is only 1. Okay. The right view indicates that the front right column is only one block high, right? Because note how it's only here, one block. Okay. The left front column is 4 blocks high. And then the right back column is 3 blocks high. Okay. And then the lowest column should be in front, so the difference in height between the columns is visible, and then we're going to connect it on the isometric paper. Okay, so now let's start. So we're going to start somewhere. And then we know that in the right side, okay, there's going to be 1 block. Okay, so it's only a block high. So just to give myself some space, start connecting. There's only 1 block high. It's a little hard to so this front right side is only 1 block high. Right, so that's here. Right. But then the next one next to it is 3 blocks high. Okay. So then I'm gonna this is going to be 3 blocks high. So 1, 2, 3. Let's go down this side. To indicate that it's 3 blocks high. 1, 2, 3. Okay, 3 blocks high. Okay. Then this is the next column, right, which we know here is going to be 4 blocks, right? So this front view takes care of this here. Okay. So next here, next to that 1 block, I know it's going to be 4 blocks. So I'm going to make it, this is already 1, 2, 3, 4 blocks high. One, 2, 3, 4. Connect. 4 blocks high. Okay, right, that's the left view. That's this part here, and then this part here, in which we see this part here. Okay. And then the one behind it is gonna be 1, 2, 3, 4, 5. So it's not only gonna be how do I do it? 1, 2, 3. So this would be 4. This would be the 4th one here, and then I need 1 more behind it. Hold on. Did I connect it weird? Sorry, I shouldn't have connected it here because I'm going to put 1 more on top of it. So, just let it dry and put 1 more on top of it. It's going to go this way. So, let's let it dry. And this way. This. There you go. Sorry, that one's a little bit messed up because of it. Right, so this is actually the 4th block, and then here's the 5th block on top of it. And there you go. Okay. So a little bit confusing. I suggest maybe using pencil, okay, to do it, just in case you need to erase. So why don't you try CYP2B. Here's a picture, and then once you're done, come check your answer. Okay, and this is what you should have gotten, something similar to this. I thought this one was slightly less complicated than our example. If you got this right, you can move on to our last example. If not, here is your explanation. Okay, so the top view part tells us that the front two are going to be the same height and the second two are going to be the same height because of, note, this only one solid line. Okay, and then I actually started with the right view first. So I knew that in the first row there will be one, or the first column, whatever you want to say, there's going to be two of them. So that I actually started drawing these two first. Okay, and then afterwards I know the one next to it is going to have 4. So then I just, oh sorry, I made it too big. Should only go up to here. It's too tall. I put too many in. Okay, it should only be 4. 1, 2, 3, 4. So 1, 2, 3, and then 4. Okay. All right. So first part is 2, and the next part is 4. Okay. Then the left is the same thing. This part is 2, and this part is 4. So you can't see the 4, but then there's 1 on the bottom. 2, 3, 4. Okay. And then the front view, right, shows us that we have 2 here. It's looking at these 2, and then the back 2 up here. Alright, and then the top view, like I said, shows that these 2 are the same height and these 2 are the same height. And there we go. Right. So really, I just started with my right view and then just built off of that. That's how I did it. Okay. Okay, so the next example, okay, talks about a carpenter wants to cut a cylindrical tree trunk into a circle, an oval, and a rectangle. How could the tree trunk be cut to each shape? Okay, and so basically, to get a circle, this is what we call cross sections. When you cut it and then look at that shape that it forms, what it is. Okay, so a circle, since it's a cylinder, that's if we just cut. What? If we just cut it directly across, that would be a circle. Okay. If we cut it diagonally, that would create an oval. Okay. And then how do we cut it to make a rectangle? If we cut it exactly like this. Vertically, then it would create a rectangle. Okay, so carpenter wants to cut. How could the tree trunk be cut to cut each shape? Horizontally would be the circle. Slanted at a diagonal would be my oval, and then vertically would be my rectangle. Okay. So why don't you try CYP3, and then once you're done, come check your answer. So if you cut it horizontally and then looked at the shape of the thing you cut, it would look like a circle. And if you cut it vertically and looked at it, it would be a semicircle. Okay? So that's it for today. Have a great rest of the day. Bye, guys.